So not just putting that the highest exponent is 3, 4, 2, you need to actually know the name or you won't get full credit. And then knowing how many terms there are, counting. So if you just put the number, that'll be half credit. I need you to actually put the name. So look at this page. Look at the problems. Whatever questions you want to go over, just want to review because it's been a while, have questions about, anything like that, find those and we'll go over those. So starting on just the first page for now. 11, okay. Any others? I'll circle them all and then we'll go through them. So 11, if you come up with another one you want to go over, have questions about, you can go through that. So in this second section, it wants you to put it in standard form. So highest exponent first, but ABC order trumps that. So ABC order, then highest exponent. So looking at these, which one would go first? Victor. Is that our highest exponent? So not that one, not 5a squared b squared. Lily? A to the third. It's also the only one with a by itself, so that one would have to go first. Then what? Hannah? So here, because these ones have A's, we have to get rid of those before we do the B. So that's why it's weird, because we're thinking highest exponent, but ABC trumps that. That's where that one would go. So 5a squared b squared. And then, Victoria, plus 2ab. And then our last one, that minus 2b to the third. So we have to get rid of all of our A's first, the A's with the B's, and then once there are no more A's, then we can move on to B. Right? It doesn't ask for this, but what is our highest exponent here? 3. And what is the name of that degree? That would be how many terms if there were 3. But degree-wise for 3, cubic. So this is a cubic function. How many terms do we have? Go ahead and say it. So we have 4 to make it a polynomial, yes. Any other questions on this page? Anything we want to review, go over, anything like that? Were you going to say something, Lily? Okay. All right. If not, move on to the next page. So we're going to quickly review these rules, and then any problems you want to see from this page, we'll do those. If we are multiplying like bases, what are we doing with the exponents? Adding. We can say this all up. So x to the a plus b. If we are raising an exponent to another exponent, what are we doing to the exponent? Multiplying. So this would be x to the a times b. When we divide like bases, what are we doing with the exponents? Subtracting. X to the a minus b. And if we have a negative exponent, what happens? Say that again. 1 over, and your exponent becomes positive. So 1 over x to the a Or, if it were flipped, 1 over x to the negative a would become a positive x to the a. Look at numbers 1 through 10 on this page. Find any questions that maybe you did, you want to go over, or see if you got it right. If you have questions about, it looks confusing, you're not sure where to start any of those. Nature? 6. Lily, number 5. Go ahead, Cameron. 2. Victoria? 4. Any others on that page? 1. We got 1, 2, 4, 5, 6. You good on 7, 8, 9, 10? Nature? 10. Lily? 7. I think this is a good amount. Did you have one? 9. Okay. So once we get through those, then we'll move on. And you probably won't have time to do all of that before lunch, but that's okay. Anyway. So starting with number 1, you are multiplying like this is. So we are adding the exponents. So anything that has actual numbers, we shouldn't have because we didn't have actual numbers in our problem. So would this be A or C? A, because we're adding, not multiplying. We're multiplying our bases, but not our exponents. For number 2, we have parentheses. Look in those first. Can we do anything inside the parentheses? No. So now we can look at both. We are multiplying these. We have 2 sets of numbers, so we're going to multiply those together. And then we are adding our exponents. If you need to, add in 1s here, so you remember to add those in. What would our 2 new exponents become? Nature? So then we would actually multiply the numbers 3 and 6. And because we got 18, it can't be A or C. And then these both have negative exponents, so they're both going to be moved down in our denominator. So D would be our final answer. Number 4, we are simplifying this. We have actual numbers, so we're going to divide or simplify them. 3 over 12 would simplify to be what? 1/4. And then we're subtracting our exponents. What would those 2 new exponents become? Go ahead, Victoria. Say the y again. -1. So then our x squared is going to stay in the numerator. Y is going to come down to the denominator. So E. Five, what would be our first step? Victoria, go ahead. So you could do that. Flip all of these up. You could do that, yes. That wasn't what I had in mind. But if you wanted to do that, yes, you could do that. X to the 5th, y squared, z to the 8th, x to... This would still be in parentheses, though. Is the only thing with that. So you could flip it up and make it positive. What else could you have done? Victoria? Simplify how? You could have also multiplied the -3 to both of these exponents. So this was x to the -3, y to the -3. Either way you do this, you're going to get the same answer. So here you would subtract your exponents. Here you would kind of distribute your exponents, but make this all the same. And then add your exponents. X and Y are the only things that have like bases. So those are the only things that are going to change. If you're subtracting, this is 5 minus a negative 3. And then if you're adding, it's just 5 and 3. So what would our answer be? Are you raising your hand? Go ahead. 8 for...
No, A.
A, sorry. Double check that. Because we're subtracting, so 5 minus negative 3, or 5 plus 3. This would be anyway. This would be a Number 6. What would be our first step? Lily?
Add 3 to the exponent.
Just 3 on the outside? You wouldn't add them to the exponents. What operation would you do? Multiply. That would be a good step, not a good first step. Think order of operations. What would we do first? Victoria. Right, the things inside the parentheses. We have like bases here, so take care of those first. The negative 2 doesn't have another number, so that's going to stay negative 2. What would our new exponents be for m, n, n? Christian?
M to the 4th and n to the 7th.
You're subtracting. So if you were adding, yes.
And n by itself.
M to the 0.
Yeah. N to the negative 1.
Then we would take that exponent and multiply it to all of the exponents to include the number 2's exponent. Negative 2 to the 3rd power would become what? Hannah? Negative 8. M to the 0 would become what? 1. Anything to the 0 is what? 1. So if we have things with M still, those aren't going to be answers. And then the n to the negative 3 would become a fraction. Multiply those all together. What would be our final answer? Victoria, go ahead. Before we get on to 7, 9, and 10, of the ones we've done so far, do we have any questions on any of those? For 7, we have this fraction exponent. If it were any other number, what would we do first? If it wasn't a fraction and it was just a number outside of those parentheses, what would we be doing with it? Multiplication. Same thing. So I'm going to rewrite this. A to the 3 times... I feel like this says 2/3, but I really can't tell. And b to the 6 times 2/3. Okay. So then, what would our 2 new exponents for this a and this b become? Again. 2 and 4. So then the rest is just combining your like bases or multiplying your like bases and adding your exponents. So the 4 is going to stay out front. What is your new exponent for A? If you're subtracting these. Adding a negative. 2 minus 3. Negative 1. And then our new exponent for B. Would be what? Say it again. If you're adding. We only subtracted because one had a negative. Lily. 10. So then our last step would be to do what? Victoria. Yes, and make it a fraction. So in our numerator, we have 4b to the 10 all over a to the first, or just a. Either or. For 9, I would say do what's in your numerator first and then focus on your denominator. So we're multiplying. So actually multiply your numbers and then do what with your exponents? If we're multiplying like bases, add. So x to the 8th, y to the 8th also. Simplify 18 over 24. What would that become? Yeah. I think it's 3. Yeah, I did that wrong in my head. 3/4. I like divided 1 by 3 and 1 by 8. Or 1 by 6 and 1 by, 3. Okay, and then our new exponents we're subtracting. So x to the negative 7, y to the 6. Our x would go in our denominator, y would stay in the numerator. So 3y to the 6, 4x to the 7. Questions on 7 or 9 before we do 10? Is very similar to 7, where we have fraction exponents. We're going to do that same process and multiply. So I'm going to write it like this. A to the 15 times 2 over 5. B to the 20 times 2 over 5. Minus 2 times a to the 30 times 1/5. B to the 40 times 1/5. What would our new exponents become? Nature? For both?
Sorry.
Okay, what would be? Yeah, 2/5. Not 8. Yes, I was saying not 4, but 8. Once you have this, you can drop the parentheses and just put 3 and negative 2 next to it. Then it becomes a problem of combining like terms, which you have to have the same variables and the same exponents. Do you have the same variables and exponents? Yes. So then I can just combine 3 and negative 2 to become 1. Or just 8 to the 6. When we get back from lunch, we'll start on the next page. Have a good lunch. Hannah. Anything you see you're not sure how to start, want to double check because you did it, have questions about anything like that? Seven. Any others? Sophia? 4.
Can you do 11?
11. Any others? We have 4, 7, 11. You got 4. Okay, starting with number 4. If we're trying to find area, we have to multiply what's given together. So you can do any of these methods. Box method, FOIL, rewriting and distributing, any of those. Sure, let's do box method. Does not matter if you put this up here or on the side. And you're multiplying each term together in each of the boxes. You're multiplying like bases, you're adding the exponents. So 2x times x would give us 2x squared. X times negative 5 would just be negative 5x. 2x times 1 would just be 2x. Negative 5 times 1 would just be negative 5. Highest exponent first, the positive 2x squared. Find your like terms, combine them. How many x's will we have? Hannah? Negative 3. And then our constant would stay the same. Dakota, do you not have this one? You have the other one. I can give you this, that way you don't have to write it down. Alright, number 7. What is the operation we're doing? What math operation do you see between the two? Adding. So if we are adding, we are just combining like terms. So find those like terms. I was about to say lobes, but they're not. So here we don't have another x squared and we don't have another x cubed, so we have to write this in standard form, negative 8x to the third plus 2x squared. We do have x's though. 3x plus a negative 3x, so 3x minus 3x would be 0, so we wouldn't put any x's. And then 5 minus 2 would give us a positive 3. We know we're done because we don't have any more things to combine. We don't have any like terms. So that is our final answer. For 11, for perimeter, we have to add up all the sides. So you can do this one of two ways. One, it only shows you two sides, but this would be the same on the other two. You can literally add up this, and then add up that again, and that again. Or multiply this by 2, multiply this by 2, and add those together. I'm going to do that one. So if we are multiplying that by 2, each by 2, what would those become? What would this first one become? You're multiplying 2 and 2. This one would be 2x squared, yes. For this first one, though. Negative. Okay. 4x squared, keep going. Minus 10x plus 2. Okay, so we have 2x squared down here. What's the rest of that, Cameron?
Plus 4x plus 6.
Then our last step, we have to add those two things together because we're looking for perimeter. So 4 plus 2 would give us 6. Negative 10 plus 4 would give us negative 6. 2 plus 6 would give us 8. Whoa. Other questions on this page? I thought I saw the multiple hands.
Did you know the 10?
So for number 10, you could do this one of two ways. With all of your subtracting problems, you can rewrite this. So it's minus, and then all of this, 4a squared plus 3a minus 7. But notice that the first one has 2, the last one has 3. So I would say put a plus 0 at the end. And then you would subtract vertically. 6 minus 4 would give us 2. Negative 5 minus 3 would give us what? Double check that, because it's negative 5 minus 3.
Oh.
Negative 8. And then 0 minus a negative 7. What would that be? Nature, sorry. Positive 7. You could have also distributed the negative to everything in the second set of parentheses, and then just combine our terms. Either way would work. Other questions on this page? Yes,
Can we do number 1?
Product means what? Multiplying. So we're doing the same thing we did in 4, using the box method or FOIL or rewriting and distributing. So I'll do a different method for this one. Let's do FOIL. So again, as I said before, if you want to write out each term, you can, or you can just write out what it is when you distribute. X times 4x would give us what?
4x squared.
4x squared. X times negative 3 is negative 3x. Negative 1 times 4 is negative 4x. Negative 1 times negative 3 is a positive 3. So when you multiply it out, you should end up with 4 terms. Then combine your like terms. So 4x squared minus 7x plus 3 would be our final answer. Right. If all of this, drawing all of this does not make sense, use the box method or rewrite it. Right. Look at the next 2 pages. Find any last minute questions you want to go over, have questions about, aren't sure how to start, anything like that. And then when you say the number, tell me what page it's on. Tell me if it's the first or the third or the fourth. Lily. This 14. Hannah. 10 on this page. Any others? Victoria? This one? These are actually the same thing, so we're just by 10. Sophia? 15? Yes. 17. Okay. So we're going to go through these kind of quickly so that way you can start working on your quiz. 10, 14, 15, 17. For number 10, at the end we're going to subtract, maybe if they have like terms, but focus on these first. We have an exponent, so let's change that. So this would become x to the second power, y to the 6. Then we are multiplying like bases. So the negative 2 is going to still be there. X squared doesn't have another like base. And we can add our exponents. Then at the end, now we're subtracting. And you have to see, do we have like terms? Do we have the same variables with the same exponents? Yes. If the answer to that is no, you would leave this as is. But I can take these 2 numbers and combine them. Leave your exponents the same. So negative 15x squared y to the 10th. This would be your answer for 10 and 11 because they're the same. I think that was accidental. I don't think it was supposed to be the same thing. For 14, we have things inside, so deal with that first. 4 over 6 would reduce to what? Two-thirds. Then we have x's and y's. 4 minus 1 would give us 3. 2 minus 1 would give us 1. Those are both positive exponents, so those would both stay in your numerator. And then you would apply the exponent to everything. So we have 2 squared, x to the 6, y squared over 3 squared. Or 4x to the 6, y squared all over 9. We have things in our numerator. Do that first before you worry about the denominator. So multiply 7 and 3. Add, or in this case, subtract your exponents. Simplify 21 over 6. What would that reduce to? Nature? 7/2. And I'm subtracting my exponents. Negative 5 minus 2 would be negative 7. So the b would get moved to the denominator. 7 over 2b to the 7. And then this last one is similar to one we did on the front page, where you can either take this and flip it up and deal with it that way, or go ahead and deal with the negative exponent, make each of these a negative exponent, so a to the 12, b to the negative 3, a to the negative 4, b to the negative 4. Subtract your exponents. What would your new exponents become? Not 8. Don't check that. Because we're subtracting a negative.
A to the 16. And then
Not negative.
B to the 16.
Or just yes. So double check your signs, double check your math in the calculator. Do we have any other general, not specific to these problems, general questions? Go ahead and clear off your desk, except your calculator and whatever you're writing with.